It was a rough day yesterday. Kimberly Newman and I had to be sent out to Cedar Point for part of Physics, Science, and Math Week. While there, we met up with our friends, good friends from the Imagination Station, who are also out there this week. Check it out. Physics, Science, and Math Week continues out here at Cedar Point. Part of that excitement, people that are always interested in science, folks out at the Imagination Station. Sarah, you guys are spending the week out here.
We are. We're so excited to talk about physics, okay?
A lot of these roller coasters that are surrounding us here at Cedar Point, they operate on the principles of physics and calculus and all that great stuff.
Yeah.
How does this all play into what we're going to be doing today?
Well, it's really important for us to talk about Sir Isaac Newton and his 3 laws of motion. All right, so I actually have an experiment that will show us some of those different laws at play, okay? So what we've got here is I've got this big cup of water, okay? And I'm going to put a lunch tray on top of it. And now I've got a tube. I'm going to balance this on top. And what we're talking about here is the first law of motion, which says that an object at rest will stay at rest unless acted on by an outside force, which is the same scenario for an object in motion. Okay, so right now we have our egg and it's resting. It's going to continue to rest until an outside force comes along and moves it, okay? So to show you this, I'm actually going to scoot these out of the way. I'm going to be the outside force, okay? You ready? So 1, 2, 3. All right.
How about that?
Now look at that, okay? So pretty awesome. What I did, I was the force that moved that tray out of the way, and our egg was resting. As soon as the tray was gone, gravity pulled it straight down into our cup where it landed safely, okay? Now,
we can maximize this experiment.
We can, right? 1 is cool, but 3 is better. So what I'm gonna do is I'm going to put these up here. I'm gonna have you grab our tray.
Okay.
All right, and these are raw eggs, okay? So that's what makes science better, right? The element of surprise. Okay, so I'm gonna balance these up here for you. Now you're gonna use the same karate chop method called the chop and stop. So you're gonna chop that tray, but you're gonna stop your hand before you knock over our glasses of water.
I don't want to get yoked with this one, do I?
All right, so you ready?
We'll see if I can master the first law.
Okay, go for it.
3, 2, 1.
Perfect, that was amazing.
All right.
All right.
How many people get that on their first try? Come on.
I don't know, I'd have to probably do some math, right, to figure that out. But again, we have also our second law of motion, so F equals ma. So the amount of force that needed to be applied was equal to the acceleration of your hand times the mass of our tray, okay? Now, to show off our third law of motion, I've got a canister here, and I'm gonna have you put a little bit of water in that.
One of those old film canisters, right?
Those prehistoric film canisters.
Kids probably don't know what these things are anymore, do they? It's all digital.
So we put a little bit of water in. I've actually got Alka-Seltzer. So I want you to drop your Alka-Seltzer in. Go ahead and put that in there.
Okay.
Now put a lid on. We're gonna trap the carbon dioxide gas that's being released inside our container. Now this is showing our third law of motion. So for every action, there's an opposite and equal reaction.
There's a lot of bubbling going on right now.
A lot of bubbling, so I'm gonna have you pull this right out there, okay? Now, eventually, there's gonna be so much pressure inside our container that the only place it can come is out, okay?
I assume mine's going to explode
I hope so.
too.
It's hard to say, right? It's like the waiting game.
The anticipate, it's like going up the hill on Millennium Force.
Right, that click, 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 click until we get to the top. But right now, there's some different variables, right? The amount of water that we use, the size of our Alka-Seltzer tablet, those are all things that change the length of our experiment.
And supposing I put the cap on tight enough.
There we go. Oh my gosh. That one's crazy high.
There we go. We go big or we go home, just like Cedar Point.
Exactly.
What's in store for you guys the rest of the week? You're going to be out here at Cedar Point.
We are. I will be out here until Friday, and then in the building we actually have Innovation Week happening, so families can stop by and check that out as well. Okay.
Did you ever think that you could learn so much being out here at Cedar Point? That's what a lot of, actually thousands of school kids are going to be doing across the area this week. And thanks again to the Imagination Station. You can visit them out here at Cedar Point. Of course, downtown Toledo as well.
Perfect.